As we continue talking about chapter 19, we are going to be talking about what's called margin of error. So, definition. The margin of error is how far the confidence interval extends on each side of p hat. So, in general, when we make our confidence intervals, we always take our estimate, which our estimate we know to be p hat, and we always add or subtract some quantity. That quantity is your margin of error, abbreviated ME. So that amount that you go up or down from p hat is what's called your margin of error. Now, if we want to increase our confidence level, in other words, we want to capture P more often, that means that we need to widen our interval. What that also means, though, is our margin of error then increases. However, if we want our margin of error to be smaller, then we need to make our interval smaller, so our confidence level goes down. So in general, if you want your confidence to go up, then your margin of error has to go up. If you want your margin of error to go down, then your confidence in your answer must also go down. And this is an important little feature that you'll probably want to write down that might come up in some later questions. So just remember, if your confidence increases, so does your margin of error. If your margin of error you want decreased, then that means your confidence has to decrease. So let's look at some problems that just involve margin of error. On January 30th to 31st, 2007, Fox News polled 900 registered voters nationwide and asked, "Do you believe global warming exists?" 82% said yes. Fox reported their margin of error to be plus or minus 3%. It is standard among pollsters to use 95% confidence levels unless otherwise stated. Given that, what does Fox News mean by claiming a margin of error of 3%? So this is just simply explaining what does margin of error in this particular problem mean. And so the answer to that simply means if this polling were done repeatedly, over and over again, 95% of all random samples would yield estimates that come within plus or minus 3% of the true proportion of all registered voters who believe global warming exists. So in other words, if we did this over and over and over again, 95% of all the samples would yield estimates that come within, there's your margin of error, plus or minus 3% of the actual answer. So the margin of error is how far off from the real answer you're allowed to be and still be considered basically acceptable. So let's look at another question that involves margin of error. A medical researcher estimates the percentage of children exposed to lead-based paint, adding that he believes his estimate has a margin of error of about 3%. Again, explain what that means. So this is just the explanation part of it. It means that he believes the true percentage of children who are exposed to lead-based paint are within 3% of his estimate. So his estimate, he makes a guess based upon a sample. He believes that the true proportion is within plus or minus 3% of his estimate. So let's look at one more problem involving margin of error. So back to that January 2007 Fox poll. They, of 900 registered voters, and again, they reported a margin of error of plus or minus 3%. It is a convention among pollsters to use a 95% confidence level and report the worst case margin of error based on a p hat of 0.5. So all this is simply asking is, instead of describe the margin of error, this wants you to actually calculate their margin of error. In other words, show how they calculated it. Well, margin of error is just that amount that you add or subtract to p hat. Well, if you remember from the previous lesson, we got that from our standard errors. So we're going to start by calculating our standard error. So we got the big square root. We need p hat, which is 0.5, times, well, if p hat is 0.5, then that means q hat is also 0.5, divided by our n, which is 900 sampled. So if you type that in the calculator, two digits after the decimal, you get 0.017. So now we go back and we said, okay, well, 95% from last lesson is 2 standard errors. So I'm going to take 2 times that 0.017, and I get 0.034. Well, if I turn that back into a percentage, because this is a decimal, that is 3.4%. So that is how they got their margin of error of 3%. We just didn't call it margin of error yet last lesson. We referred to it as the appropriate number of standard errors. So it's exactly what we've done before. But this leads us to our next topic. Critical values. Critical value definition. These are the number of standard errors to move away from the mean of the sampling distribution to correspond to the specified level of confidence. Well, last lesson we learned that if the level of confidence was 68%, it was 1 standard error, 95% was 2 standard errors, and 99.7% was 3 standard errors. Well, those, believe it or not, were just approximations. They were based on the rough normal model that we learned in Chapter 6. Well, we're going to have, obviously, other confidence levels that are going to pop up. We might want to find 90% or 85% or 75%. So how do we find those other ones? Well, that's what the first part of this lesson is what is the actual accurate way of finding the number of standard errors. So there are easy instructions to find your critical values. First thing, draw your normal model and show your confidence interval that the question's asking for. Then you need to calculate the percentage needed to look up on your blue sheet. To do that, you take 100 minus your confidence interval. Notice it's in parentheses so that you do that first, and divide that by 2. That's going to give you a percentage that you need to look up on your blue sheet. Now, for us, we are always going to use the negative side of your blue sheet. So you go to the negative side of your blue sheet, or if you remember calculator shortcuts, you can use those as well. You are actually looking up the percentage, so make sure you look in the middle of the blue sheet for the number that is closest to that decimal that we just found. Once you've found that, you go left and you go up and you find the z-score that is appropriate. But the only thing is, because these are critical values, because these are talking about standard errors, we're simply always going to use the positive z-score that comes from that blue sheet. So we're going to look at how to find the accurate critical value for 95% confidence interval. If you remember from last lesson, 95 was always 2 standard errors. We're going to see how close we actually are to that 2 standard errors. So first we're going to start by sketching a picture. So 95%, what we knew from last lesson, normal model. We have the dead center, which is always P. 95 was 2 marks or 2 standard errors out. So this area right here represented the 95% confidence. So to use our little step-by-step instructions, we've now drawn our picture. We need to calculate the percentage that we need to look up on our blue sheet. So in parentheses, we need to take 100 minus 95, close parentheses, divided by 2. So if you calculate that, I end up with 2.5%. Well, that needs to be turned to a decimal in order to look it up on the blue sheet. So if you remember, all we have to do is take that decimal, move it 2 spots to the left, or divide by 100. If you prefer to divide by 100, you can do that. But you're looking up 0.025 on your blue sheet. So go to the negative side. You're looking in the dead center for 0.025, and there's actually an exact value. Okay, there isn't, you don't even need to look for the one that's closest. There is a 0.0250 in the center. If you follow over, I get a negative 1.9, and if you follow up, I get a 6. So this represents a z-star score of, and we drop the negative part, 1.96. So the 2 standard errors that we used last lesson was an approximation. From this point forward, all questions that use 95% confidence interval will always be this number right here. Now you can do one of two things. You can memorize that number for 95%, or anytime it comes up, you can calculate it again. So let's try another one. Let's try one that we haven't seen before. Calculate the critical value for a 90% confidence interval. So we know 90%, here's the middle P. We know it's past the 1 because the 1s were 68. So somewhere out here, this area right here represents 90%. So to find our number, we first need to take in parentheses 100 minus 90, close parentheses, divided by 2, and you should get 5%, which we need to divide by 100 or move the decimal, and it changes to 0.05. So go to your blue sheet, go to the negative side, and we're looking for 0.05, and I guess 00 would be the 2 digits after. So I'm seeing two possibilities. I'm seeing 0.0495, and I'm seeing 0.0505. Well, if you notice, this one is a 5 below and this one's a 5 above. So let's find those two z-scores. So the first one was a z-score of negative 1 point, whoa. Let's try that again. Our first one was a z-score of negative 1.64, and this one was a z-score of negative 1.65. So what we're simply going to do is, because it's directly in the middle of the two, we're going to split the difference. So we're just going to use a positive. So here's that negative, because we don't need the negative part of it. We're going to take 1.64 plus 1.65. We're going to hit enter. We're going to divide that by 2, and you get a z-star score of 1.645. So this will be the number we will always use for 90%. So again, if you don't want to recalculate it every time, 90%, 1.645, 95%, 1.96. And as you do these in your homework, you can simply memorize the different values. And I am perfectly acceptable. If you take the time to memorize them, you are allowed to use them on the test without having to show the work. So now that we've done a couple of these, let's go back and look at some more specific others. So if you think back to the example 6 that we were talking about, the news poll of 900 registered voters, finding that now 82% of those respondents believe that global warming exists. Now Fox News reported 95% confidence interval with a margin of error of plus or minus 3%. We want to know if we changed to 90%, from 95%, what would be the new margin of error? And so if you remember from that slide when we first learned margin of error, if our confidence level is going down, that means that our margin of error is going down. So let's do some number crunching. So we know from before, we got to find the standard error. We'll just find it again real quick. Square root p hat was 0.5, which means q hat is also 0.5, divided by 900. So the standard error came out to be 0.017. We already calculated that. Now, 90% means that we need 1.645 as our critical value times 0.017. So that gives us a margin of error of 0.028, which if we change it to a percentage is 2.8%. So what's good and bad about this change? Well, the good part is the margin of error got smaller. That's the good. But the bad is our confidence level also went down. So we're not as confident in our interval, but our margin of error did get better. So in general, let's summarize what we're talking about here. So when we are talking about confidence intervals, the fancier name for a confidence interval is a one proportion z interval because it's based on z-scores. When all of our conditions are met, again, that's the random 10% NP hat and NQ hat, we are ready to find the confidence interval for the population proportion P. So our general formula for all confidence intervals is P hat plus or minus Z star, which is our critical value, times square root of P hat Q hat divided by N, which is our standard error. And always, always write your final answer as an interval. So we're going to practice a couple of examples and then we will be done. So in May 2006, the Gallup poll asked 510 randomly sampled adults the question, generally speaking, do you believe the death penalty is applied fairly or unfairly in this country today? Of those that were sampled, 60% answered fairly, 35% said unfairly, and 4% said they didn't know. From this survey, what would be a confidence interval for the percentage of people who answered fairly? So the only number that we are focused on is the 60% for fairly. So if we go through our process, we always have to check our conditions. So let's do some condition checking. So first thing, is it random? Did we see anywhere up in here about the word about, oh yeah, see it says randomly right there. So we're good. 10%. What was our sample size? Well, that was 510. Add an extra 0. Do you think there's at least 5,100 adults in the U.S.? I would say that that is very safe to assume. What about NP hat and NQ hat? Well, N is 510. P is the percentage, the 60%, so 0.60. So that gives us 306, definitely higher than 10. And 510 times, well, the leftover percentage will be 40%. And that leaves us with 204. So both of those are good to go, which means we can go ahead and check mark our conditions. Next thing we need to find is our standard error. Big square root. P hat, 0.60, times Q hat, 0.40 divided by n, 510. So if you put that in the calculator, 2 digits after the 0 comes out to be 0.022. Now, the next thing we need to figure out is our margin of error. So that's our critical value. Well, here's the one thing you notice we don't have, is a confidence level. So as a general rule of thumb, if no confidence level is given, automatically use 95. That's going to be our general rule of thumb if we're ever missing a confidence level. So, 95. What is the number that we found back in example 7? Well, our new specific number for 95 is not 2, it's 1.96 times 0.022. So our margin of error comes out to be 0.04312. Notice I didn't do any rounding. We'll round when we give final answers. So to find our confidence interval, we need to take p hat, 0.60, plus or minus the number we just found, 0.4312. So our low number, if we take 0.60 minus, we get 0.557. And if we take 0.60 plus that decimal, we get 0.643. And so, if you remember our little fill in the blank statement, so we are 95% confident that the true proportion of Americans that think the death penalty is fair is between 55.7% and 64.3%. Alrighty, so that is the only difference. The only thing that we changed from day one is just now we're using that 1.96, those exact values, versus what we did before. Direct mail advertisers sends solicitations, aka junk mail, to thousands of potential customers in hope that some will buy the company's product. The acceptance rate is usually quite low. Suppose a company wants to test the response to a new flyer and send it to 1,000 people randomly selected from their mailing list of over 200,000 people. They get orders from 123 of the recipients. Create a 90% confidence interval for the percentage of people the company contacts who may want to buy something. Okay, so let's start with the important ones. The conditions. Random. It says right here, randomly selected, so we're good there. 10%. They send out their flyer to 1,000 people. Add a 0, we get 10,000. Do you think there is 10,000 people who receive junk mail? I would say yes. So NP hat and NQ hat. Well, here's the problem. We know N's 1,000, but we don't know P hat. So we got to calculate P hat first. So P hat, we know they sent out a mailing to 1,000 people. 123 out of those 1,000 decided to place an order? No. Yeah, decided to place an order. So 123 divided by 1,000 is 0.123. So that's what we're going to multiply by, 0.123. So 1,000 times 0.123 is 123. So now we got to do 1,000 times, if you take 1 minus 0.123, you get 0.977. And when you multiply, you get 977. So both of those are bigger than 10. Our conditions are good to go. So next piece of the puzzle is standard error. Big square root. So we have 0.123 times 0.977 divided by 1,000 people. So I get 0.0 and then I get 10 after that. So there's our standard error. Now let's find our margin of error. Well, 90%, if you go back and you look at example 8, we did 90%. That was your 1.645 times 0.010 leaves you with 0.01645. So finally, we need to take our p hat, which is 0.123, and add or subtract 0.01645. So let's start with the low. If you take 0.123 and you subtract that decimal, I get 0.107. And if you take 0.123 and you add 0.016, I get 0.139. And I'm not going to answer the sentence yet because that's on the next page. So explain what this interval means. It means we are 90% confident that the true proportion of people who buy something is between 10.7% and 13.9%. So there is your sentence. Explain what 90% confidence means. What that simply means is 90% of our samples will contain P, like the real P, not P hat, the real P. Well, now there's a follow-up question. The company must decide whether to now do a mass mailing. The mailing won't be cost-effective unless it produces at least a 5% return. What does your confidence interval suggest? Well, our interval suggests that 10.7 to 13.9% will buy something. So they'll get a profit if we hit at least 5%. So our interval is definitely above 5%. So it will be cost effective. Alrighty, one more example. A city ballot includes a local initiative that would legalize gambling. The issue is hotly contested, and two groups decide to conduct polls to predict the outcome. So we have the local newspaper. They find that 53% of 1,200 randomly selected voters plan to vote yes. Then we have a college stats class that finds that 54% of 450 randomly selected voters are in support. Both groups are going to create a 95% confidence interval. So, without actually finding the confidence interval, explain which one will have a larger margin of error. Well, that is very simple. Your margin of error is based upon your standard error. And if you remember, that formula is P hat, Q hat divided by N. this guy right here is your deciding factor because that's what you're dividing by. If you divide by something bigger, your answer will get smaller because you're dividing it up into more people. So who's going to have the larger margin of error? The one with the smaller sample size. And so the stats class will have a larger margin of error because they have a smaller sample size. Oops. So, and that's just simply based on the fact that we have the n there. So now let's find both of our confidence intervals. So I'm going to divide this in half and we're going to do the newspaper on one side. So this is going to be our news and this is going to be the stats class. Okay, so because of the sake of space, I'm not going to bother with my conditions. I can tell you that your conditions are fine. So let's go through our standard error. So standard error for the news, their p-value was 53%. So 0.53 times the leftovers are 47 divided by 1200 gives a standard error of 0.014. We said what confidence interval? 95%. And so we need margin of errors. So 1.9, I don't know why there we go. 1.9, I'm sorry. My iPad's going nuts. Okay, let's try this again. Okay, we're having technical difficulties. Let's try that again. So the newspaper. So their standard error, as I had started to write, was 0.53 times 0.47 divided by 1200, which had come out to be 0.014. 0.014. Margin of error we went on to find for 95%, which is 1.96 times 0.014, and I get an answer of 0.02744. So my confidence interval will be my p hat, 0.53, plus or minus the 0.02744 that we just found. So if I take 0.53 and I subtract the 0.02744, I get 0.502. And if I take and I add that number, I get 0.557. Okay, so now let's go on to the stats class. So the standard error, their standard error is going to be slightly different. Their p-hat was, if we look back, 54%, so 0.54, times the leftovers would then be 0.46 divided by, and their sample size was 450. So their margin of error came out to be 0.023. So notice that's quite a bit bigger. So our margin of error, we still need that 1.96 times 0.023, and we get we get 0.04508. So now the confidence interval, 0.54 is their p-hat, plus or minus 0.04508. So they're low, if we take 0.54 and we subtract 0.04508, I get 0.494. And if I take 0.54 and I add 0.04508, I get 0.585. So, which group concludes that the outcome is too close to call? So, with voting, as you know, you simply have to have a majority to win. You have to have more than 50%. Well, if you look at the news is predicting 50.2% to 55.7%, whereas the stats class is predicting 49.4% to 58.5%. Even though their top number is higher, their bottom number is below 50%. So the group that concludes it's too close to call would be the stats class, because their interval goes below the 50% needed to win. And so just remember, when you are doing your work today, all of your critical values now, instead of the 1, 2, 3 from the first lesson, we're using the new numbers that you now have to calculate.